your dad? I don't know. And I talked to her dad. Her dad's name is Randy. I said, Randy, this is what Amy said to me today. He said, yeah, she's pretty smart. She has her PhD. In math, she went to Case Western University in Cleveland. She's still smart. Anyway, I love that distinction. Here's the other one I like. I taught an online class at OSU years ago, and on the first homework assignment, that was one of the questions I asked the students. What's the difference between weather and climate? And I got some good dictionary answers like yours, and then I got one from a young lady who said, climate tells me what kinds of clothes to buy, and weather tells me what to wear. Okay, I can relate to that. So I'm kind of talking about both, and they're all just sort of mixed up. But the question, sorry about this, if you can't, I'll read what these are supposed to say. The question everyone is asking is, what causes climate to change? If there is climate change, what causes it? Is it human causes like greenhouse gases and land use change, smoke, dust, aerosols, air pollutants, and stuff? Or is it natural causes like sunlight variations, ocean conditions, volcanoes, and stuff? There's a real simple answer to that question. Yes. Yes. Some combination of those things. Now, a lot of people focus on a single or maybe two items, but in many ways we really don't know. But I'm going to try to address what we do know and offer my opinion on what is the dominant cause of change. Greenhouse gases get blamed for everything. The greenhouse effect is a very important part of the Earth's system, the natural system. And what this is there's certain gases which are invisible. All gases are invisible, but they allow sunlight to pass through, and when the sunlight hits the ground or the surface, the ocean, it is converted from visible light or visible radiation to infrared radiation. Can anybody come up with a simpler couple of words for that? Light becomes heat. And some of that heat that passes through those invisible gases is absorbed by some of those gases. So the greenhouse gases are essential for life on Earth. They're essential. The number one greenhouse gas by far is water vapor. It represents about 95% of that 60-degree greenhouse effect. And then the next two in order are carbon dioxide and methane, and then there are a bunch of little minor ones. But the idea behind the enhanced greenhouse effect is that if we change the chemistry of the atmosphere, we will change the temperature. Carbon dioxide has been rising for quite a while. This is a chart starting in 1960, and there's a seasonal variation because of differences in the southern and northern hemispheres, but there's been a steady rise in carbon dioxide, and now we're at about 400 parts per million, which is only about 1% of what water vapor is. So even though it's important, it's not trivial. It's not that big either. But it's likely that this will continue, and all else being equal, if everything else stays exactly the way it's been, and we increase the amount of CO2, then there will be a warming. Let's look at some measurement locations. First of all, we are blessed in Corvallis to have one of the finest measurement sites in the country. It's out on the Hislop Experiment Station on Highway 20. And the thing about it that's great is that there's been virtually no land use change around this. This is pretty much a pristine, unchanged, constant site, and it's been there since 1952. And we have measurements in Corvallis that go back to 1889. So this is a good station to judge long-term trends. Portland Airport's not a very good one because there's been so much land use change around it that there's a warming around it that's as much due to asphalt and concrete and trucks and cars than it is to the natural environment. So our measurement station, the Hislop experiment station, is one of the best for looking at long-term trends that are unaffected by changes in land use. And this is what we see. If we look back to 1900, the annual average temperature, overall it's about 52 degrees. But what you notice are spikes in certain warm years and then downward spikes, if you will, for certain cool years. But when I look at this, I notice this period right in here. Most of the 1930s or the late 20s through the early 40s. That was the warmest period we've seen in Corvallis. It's also the warmest year we've seen in the U.S. The warmest year of all in Corvallis was 1939. The second warmest year was 1934. The warmest decade was the 30s. But notice, if you will, also, there's a tendency for kind of a cycle to go along. We're back in the early part of the record, it was relatively cool. And then it got warmer in the 20s, 30s, and early 40s. Then it got cool again. And then it got warm again. And for the last 20 years, it's actually been getting cooler, in spite of what you may have heard. So when I look at this, and I look at a lot of data, I tend to see these cycles all over. And this one will pop up quite a few times. So this is the annual temperature since 1992. Again, it's getting cooler. In another 20 years, we may not be able to grow tomatoes. Or things. Now, if we look at the 18 western states and look at the all-time temperature records, the all-time extremes, and what decades they were set in, what color is this? Kind of a magenta right here? You call that violet? Does that work? Yeah. Okay. The magenta show the high records, high temperature records. Like in Corvallis, our warmest day ever was in 1981. It was 108 degrees. So in Corvallis, that would be in the 1980s. And so we do this for all the stations in the western U.S. And the biggest spike in both the magenta and the violet, the low and the high temperatures occurred in the 1930s. What we're seeing since the 1930s is actually fewer extremes. The news media is all over extremes. You know, it's cold extremes, it's warm extremes. We just had one of the warmest summers we've ever had, and I'm seeing stuff all over about that. Yeah. And it's causing fires, and it's causing drought, and yeah, okay. I'm going to skip that one. I'm going to skip that one too. Tornadoes. People are talking about severe weather, hurricanes and tornadoes. In 2005, the year of Hurricane Katrina, there was all kinds of talk about, including Al Gore, who claimed that we were seeing an upward swing in hurricanes because of global warming, and they were only going to get worse. Well, this is tornadoes, and there are some really bad years, like 1974. 2012 was kind of moderately bad, but overall, those are going down as well. We have radar, and we have people that go out looking for tornadoes. They're not showing up in bigger numbers. So my summary about that is, in Oregon and the Northwest in the U.S., the warmest decade of the last 100 years was in the 1930s, and we don't see a steady increase or decrease. We see cycles. Snowpack. How many of you think snow is pretty important?
Yep.
Why?
Water.
Yeah, but why does it matter? Well, here's why it matters. That's a trick question, sorry. It matters because we like to ski. Well, there are two ironies of western U.S. precipitation. The first is, most of the precipitation falls in the winter. About 80% of our precipitation in western Oregon falls between October and March. You already knew that. It's well known. And it tends to be true pretty much west-wide. Winter is the wet season. And then the second irony is that most of the precipitation falls at the higher elevations. Generally speaking, the higher up you get, the wetter it gets. But most of the demand is in the lower elevations. And what season is the demand in? It's in the summer. Because irrigated agriculture is the number one usage of water. And the biggest demand is in the summer. And of course, in our lawns and gardens and all that, the demand is higher. So how can we enable, or how can nature enable, high elevation winter precipitation to still be available the following summer at the low elevations?
Reservoirs.
Two ways I'm thinking of.
Snowpack. Melting.
Three ways. Reservoirs, yes.
Dams.
We can build more dams. Lots of luck. What else? There's groundwater is another one I'm thinking of, but there's a third one. Snow. Snow. Yeah. So if the snow went away, or if there was a lot less snow, some people are saying, in fact, your state climatologist, my replacement, Phil Mote, says snowpack is going away because of global warming. That would be a bummer. And that's an official scientific term. In 2009, the governor of Washington, Christine Gregoire, issued a statement. In a study last month, the University of Washington showed that we've already lost 20% of our snowpack over the last 30 years. That would be a bummer. Well, I have a friend who used to be the state climatologist in Washington until he got fired because he agreed with me. That's not, I mean, yeah, whatever. Anyway, so he decided, his name is Mark Albright, and he decided to look into this and say, you know, what's really happened? He didn't think that was right. So he did a chart and he sent it to me. Snowpack over 30 years. And there's what it showed. This is for all of the snowfall stations in the foothills and the mountains of Oregon and Washington. And I'll guide you through this, but these are the individual years. And here's the best fit line. And notice the best fit line is going upward. Upward. There's more snow. So maybe that's what she meant. We've already gained 20% of our snowpack. That's what it was. Well, that's what happened. And then in Oregon, in 2005, the governor had a climate working group. One might think that the state climatologist would be invited to that working group.